Welcome to Study Loop.
Hello everyone, today we're doing chapter 23, problem 76, and this problem asks us to draw the stepwise mechanism to obtain product X, and then from X going to this final product. So if you see here, we're starting with this product, or the starting material C, and reacting it with this organometallic alkyl group here. So this carbon is actually going to kind of, you can think of it's going to dissociate with this. So you have lithium plus and CH3 minus. So your CH3 minus is going to act as your nucleophile and attack the most electrophilic center, that being the carbonyl carbon here. So you're going to have a nucleophilic attack at this carbonyl carbon here to make a bond. When you make a bond, you break a bond. So this carbonyl bond is going to break and go onto the oxygen nucleus. So you have an O minus, and then new methyl bond they just added. And now from here, this is product X. So from here, you're adding an aqueous acid. So you're adding H3O plus. So what can happen is that this O minus can pick up 2 protons to become H2O plus. So it can pick up some protons to become H2O plus. And at which point, you have OH2 plus. At which point, water will spontaneously fall off because it just wants to neutralize itself. A lot more favorable like that. So then we're going to get a carbocation intermediate. And for simplistic states, I'm going to make a let statement. I'm going to say, let this group equal R, because this group does not do anything in our reaction. So then we have that R, and we have water that fell off, and we have a carbocation now being formed here. So this carbocation can actually be stabilized by resonance by moving this pi bond around. So actually, this ethoxide group is actually on the other side of the double bond. So I'm just going to draw that on the other side of the double bond. So we actually have this ethoxide on this side of the double bond here. So now we moved over this pi bond. We're now placing the carbocation on this carbon here. So if you see that, now we have a carbocation on this carbon, which is now a tertiary carbocation stabilized by resonance. At which point now this water can now neutralize this carbocation by attacking this position. So now we can form now this protonated water, in which another water molecule can deprotonate it to form just OH alone. So what can happen, so let's work through this. So two things can happen. Number one, another water molecule can deprotonate this, but alternatively, this oxygen that's right adjacent to it can pick up one of these protons. So with this oxygen adjacent to it picking up one of these protons, we now have oxygen with 3 bonds here. And that's not that favorable, but what can happen is now this oxygen with its lone pair electrons can now form a new carbonyl bond here, making a bond. You make a bond, you break a bond, and now this oxygen, not happy to be positively charged, is more than happy to accept those 2 electrons in the sigma bond to neutralize itself. Plus, you have now ethanol. And now this is actually your final product in which water will deprotonate this carbonyl group to just form this ketone, and this will yield your final product as shown in the question stem. Just like this.